Well, this discussion, as you can see, is going to be about rational expressions. And first we need to recognize rational, of course, the word ratio is in it, and ratio we need to think of in terms of a fraction. So rational expressions are nothing more than expressions involving fractions. And sometimes we might even call them algebraic fractions, because they're fractions that involve variables. Okay, that's what we really mean by rational expressions. Now, the first thing that we would like to do is to express in lowest terms. You might see directions that say express in lowest terms, or you might see something that says simplify, or you might just see reduce, because one of the things that we do with fractions, even fractions with numbers, for instance, 6/9, we reduce that to 2/3, don't we? And we want to do the same thing with rational expressions. We want to make them in their most reduced form. And so we might see an example. We might be asked, for instance, to simplify or express in lowest terms. So let's suppose those are what our directions are. Express in lowest terms. So all that means we're going to be simplifying or reducing some fractions. So example 1, we're expressing in lowest terms. Example 1 is the fraction, let's say 5x minus 15 divided by 8x minus 24. Now, we should have learned how to do this in a previous course, and so I'm not going to belabor the point. I'm going to show you the pitfalls and remind you of some examples, as all of these little sessions are about. Remember, here's the main thing to remember. To reduce, which is basically what we're going to try to do, is we're trying to cancel, aren't we? To reduce is like canceling. To reduce, we must factor first. Always remember that. And if you always remember that, then you won't make an error and do something wrong. So for this fraction 5x minus 15 over 8x minus 24, we have to look at that numerator and we have to say, is there a way to factor that numerator? And I'm sure you're way ahead of me. 5 is a common factor, isn't it? 5 times x minus 3 is the way that we can factor that numerator. And the denominator, let's see, 8 goes into 8x and into 24 both. So 8's a common factor. We can factor 8 out. 8 times x is 8x, and 8 times negative 3 is negative 24. And now that we have it factored, the numerator and denominator both factored, x minus 3 is a factor on top, x minus 3 is a factor on bottom, and so we're allowed to cancel those x minus 3's, and this fraction just simplifies or reduces to just 5 over 8. And we wouldn't have known that by just looking at it. We wouldn't have known that. Okay, well, let's look at another example here. Let's see, let me gather some information. I apologize. In fact, let me pause for just a moment. Okay, here's the next example I want to look at. Once again, we're to reduce or express in lowest terms the fraction 3x squared plus 3x minus 6 over x squared minus 4. Now, this isn't an equation, so we don't do this idea of dividing out. See, we see 3x squared plus 3x minus 6, there's a common factor of 3 all the way through, but we can't do a dividing out because we're not dealing with an equation. What we need to do in this case, and I'm going to start down here working on the problem. So let me rewrite it. 3x squared plus 3x minus 6. We've got to see whether this is reducible, and that really means we've got to know what the factors of the numerator and denominator are. So we're back to this idea: to reduce a fraction, we have to first factor the numerator and denominator. Now I'm looking at that denominator, x squared minus 4, and that's pretty easy to factor. That's just the difference of two squares, and so I can get that out of the way real quickly. That's x plus 2 times x minus 2. And it looks like the numerator is going to take a little bit more work. But I do notice that 3 is a common factor. And so in the numerator, I'm going to factor out a 3 before I do anything else. 3 times what? X squared plus x minus 2. Now, that's just the first step of factoring. I think I can factor that resulting trinomial. So I'm going to rewrite the denominator. And I've got the 3 that's in front of this, and that trinomial, x squared plus x minus 2, I believe I can factor. That's an x times an x. The negative in front of the 2 tells us that these signs have to be different. And I'm believing that if I put a plus 1 there and a 2 in that position, that, oh no, I've got that wrong, don't I? Okay, that actually gives me a negative x in the middle. So what I really want, I blew that. Let me change that, because see, that really needs to be the 2, and that needs to be the 1. So let me change that and rewrite this as 3 times x plus 2 times x minus 1. Now the lesson to learn from what just happened here is don't get in such a hurry. You can use some scratch paper here over on the side. You can use some scratch paper to make sure that you've got it factored correctly. But now I'm convinced that I do have it factored correctly. And so what we do next, of course, is we compare the factors on top with the factors on bottom. And we notice there's an x plus 2 factor on top and an x plus 2 factor on bottom, so we can cancel those. And so what we have left on top is 3 times x minus 1. And on bottom, we just have x minus 2. And since there's nothing else, we don't really need to put parentheses around that. And so that really, and we could multiply out the top if we wanted to. We could say that that's 3x minus 3 over x minus 2. But a lot of times we leave it in the boxed form, which really is indicating that we've already factored and reduced. We don't have to try factoring again. We're kind of indicating that with the fact that it's in factored form. But there is a reduced form in this problem. So there's nothing really new here that we've done so far. But I think the next example or two is going to illustrate some pitfalls. And that's really what I'm concerned about, is dealing with pitfalls or not making silly mistakes. So let's go to the next page. Okay, we're being asked to reduce this more substantial rational expression, x squared minus 6x plus 9 over x squared plus 10x plus 9. And you know, I guess what I'm wanting to illustrate here is if we're a sloppy student, we can make sloppy mistakes. You know, and that is, we can look at this and say, oh, look, I can cancel those 9s, and I can cancel those x squareds, and I can cancel those x's, and that leaves just negative 6 over 10. And that will reduce, of course, let's see, 2 goes into negative 6 3 times and a 10 5 times, so that reduces to negative 3/5. But you know that's bunk, don't you? It's easy to fall into a trap like that, but you know, we're not allowed to cancel before we factor. So to reduce a fraction, we have to have everything in factored form. So let's go back and start on this problem the correct way. Okay, so we need to factor the numerator and factor the denominator. Now, when we factor that numerator, that's a trinomial. I guess one thing I want you to recognize about these problems, that is, I go through the factoring pretty quickly. And that's because I have a lot of experience. It may take you a little longer to go through the factoring, but I'm convinced you can do it. But you have to spend your time. So don't be misled by thinking I'm going to be able to factor everything by just looking at it rather than experimenting. But in the x squared minus 6x plus 9, obviously we have to have an x times an x. And the plus 9, that plus tells us the signs are the same. We either have plus plus or minus minus. But since we have that minus 6x, we know they have to be a minus and a minus. And so then we start thinking about, well, how do we multiply and to get a 9? And we can either say 1 times 9 or 3 times 3. And I think if you'll investigate, you actually recognize that it's going to require a 3-3 combination. That factorization is correct. Now on bottom, and see there we have two factors, but they're the same factor, aren't they? On bottom, we'll have an x times an x again, and we have a plus 9, which means both signs are the same. But we have a plus 10x, so we can't have negatives, otherwise negatives would appear. So we have to have 2 pluses in this case. And now when we look at, we have to be careful again, because we might try to force something that's not true. But when we look at the ways to get 9, it's a 3 and a 3 combination, or a 1 and a 9 combination. And I think if you'll think about this a bit, the 1 and the 9 combination is the only thing that will work. That's the correct factorization. Now, I chose this problem for 2 reasons. Not to make the first set of mistakes that we made up here, and to also notice that we can't reduce every fraction. I mean, we've attempted here, but we don't have any common factors in the numerator and denominator. So it's already in reduced form, isn't it? Already in reduced form. There's nothing else that we can do to this to simplify it. So here was an example where we did a lot of work and got not much results, but that might happen. Let's see, let's look at another example here. Hold on. Okay, this example is kind of the idea to reinforce what not to do again. If we were not paying attention and we saw the plus 3 on the end of each of these, then it might be very easy for us to say, oh, let's cancel those 3's. And so on top I have x squared plus 4x left, and on bottom I just have an x. And then when I factor that numerator, I have a common factor of x, and so that would be x times x plus 4. And with that x on bottom, I can now cancel this x, and that leaves me x plus 4. And that might be a convincing argument. But again, we know that's wrong, because what happened? We canceled before we factored. We canceled those plus 3's before we factored. So what we've done there is completely incorrect. Let's start over the correct way. X squared plus 4x plus 3 divided by x plus 3. Now, we need to factor. Now, on bottom, we can't factor x plus 3, so we've got to think of that as the single factor. On top, I think we can factor that as x plus 3 times x plus 1. And you can verify that if you'd like, but I'm convinced that that's correct. Now what we see is we have an x plus 3 factor on top, and on bottom, that x plus 3 is the factor, so that whole thing is canceling. We're not canceling an x and a 3, we're canceling x plus 3. And so that leaves an x plus 1 on top and a 1 on bottom, of course, or that just reduces simply to x plus 1. So there's the reduced form of that fraction. Now, we might have to use other techniques of factoring. That is, we might have something that looks like, let's see this one. What is this? Example 5. And again, we're asked to reduce. And this time we're reducing x cubed minus 1 over x squared minus 1. And we know already that we can't cancel those minus 1's. So we have to first factor, and on bottom it's easy to factor. X squared minus 1 is the difference of 2 squares, so that's x plus 1 times x minus 1. But on top, that's the difference of 2 cubes. And we talked about that previously. Remember, to factor the difference of two cubes, the idea is if we have a cubed minus b cubed, then that's factors as a minus b times a squared plus ab plus b squared. And in this case, what we're cubing to get x cubed is an x, and what we're cubing to get a 1 is a 1. And so that top factors as x minus 1 times a trinomial that's x squared plus the a, remember, is x, and the b, remember, is 1. And so a times b is just x. And of course, b, we have a plus here, and b being 1, when we square that, we get 1. So in this particular case, we have an x minus 1 factor that appears on top, an x minus 1 factor that appears on bottom. And so when we reduce this fraction, and remember that trinomial, when we factor a difference of two cubes, is generally prime or an irreducible quadratic. So we can't do any more. Don't get carried away and cancel the x on top with the x on bottom and the 1 on top with 1 on bottom, because they're not in factored form. We cannot factor. So this is the final answer. Be careful and don't continue when it's not possible. Okay, on the next page, I want to do some simplifying of other types of fractions, and then we'll get some that are more complicated, and then we'll talk about some other issues with rational expressions. This example 6 looks like maybe it's a little simpler than some of the other more complicated rational expressions we've had. And I've chosen it because I want to show you that there's an alternative method when our denominator of our rational expression is one term. That is, it doesn't have any additions or subtractions in the denominator, a single term. But if we were to reduce, what we've learned so far is that we need to factor before we reduce. And so one method of dealing with this particular example, and I'll call it method A here, is doing that factoring. And so we look at that numerator, and we see that 4 goes into 4x cubed and to minus 8x squared. So 4 is a common factor, isn't it? And x appears in both terms, x cubed and x squared. And so as the greatest common factor, we use the lowest of those two powers, x squared. And then, of course, we're going to have let's see here, when we factor this, 4x squared times what gives 4x cubed? Well, times x, doesn't it? And then we have to have a minus sign, and 4x squared times what gives 8x squared? Of course, a 2. So we've factored that numerator, and our denominator is 4x squared. And so now we have the opportunity, of course, to cancel the two factors, 4x squared and 4x squared. And so that leaves simply x minus 2. And that certainly works. Now, before we do the second method, I want you to think about how we add fractions. Think about adding fractions. And what I mean by that is if we had, let's take the fraction 5 over 17 plus 3 over 17. Now, because each of those denominators is 17, then we take we keep that denominator and we add together the numerators. And I know that's 8 over 17. Now, what I'm really wanting you to think about is how we can break apart a fraction when the bottom doesn't have a plus or minus in it and the top does. See, because that 5 plus 3 over 17 could have come from the 5 over 17 plus a 3 over 17. And that's what the second method relies on. When our divisor doesn't have a plus or a minus in it, like our situation here, 4x cubed minus 8x squared divided by 4x squared. What we could do in this special circumstance is we could break this into two fractions. We could write this as 4x cubed over 4x squared minus 8x squared over 4x squared. So we could do it that way. And actually, this says 4x squared divides into both of those parts, and we're just showing that by writing two fractions. And then in that first fraction, the 4's cancel, and x cubed over x squared is just x, isn't it? And in that second fraction, the x squared is a factor on top and on bottom, so the x squareds will cancel, and 8 over 4 is 2. And so we got the same result, not by factoring, but by breaking this into more than one fraction. Now, that's really necessary, or that is a way, then, that we might see when we are solving a quadratic equation by using the quadratic formula. We might need to simplify something that looks like this. Simplify, let's say, 3 plus or minus 15 times the square root of 7, all divided by 3. Now, we're tempted to cancel those 3's, but we're dealing with a fraction, and you can't cancel before you factor, or you use method method B. So let me talk about, there's two ways to deal with this. The method A says, take that fraction and factor where you can. And so on top, we notice that the factor 3 goes into 3 and it goes into 15. So we could write this as 3 times, well, 3 times 1 is how we get that first 3, and then our plus or minus. And 3 times a 5, we need to get the 15, but of course we also have the square root of 7. And then we have the 3 on bottom, and so we can now cancel that common factor of 3, and we're left with 1 plus or minus 5 root 7. Now that's the factoring technique. We could have also done this in method B, and that's break that into two fractions. So we'll start over. 3 plus or minus 15 root 7 divided by 3. Well, that says 3 divides into both of those terms. We can take that 3 in front, divide by 3, plus or minus that 15 root 7, and also divide by 3. We just wrote it as two fractions added or subtracted together. Well, of course, the 3 over 3 is simply 1, isn't it? And that 15 over 3, we can think of 15 as 3 times 5, and so that 3 is a factor, and this 3 will cancel, and so we're left with a 5 root 7, and you see we get the same result. So that's an important recognition that we could simplify this in using a couple of different techniques, but we will get the same result. Okay, on this problem, this is obviously substantial, and when it comes into the middle of this course, when we're really doing calculus, this might be the way the answer to a problem looks, but this is not in its simplest form. And this is certainly a rational expression, it's just very messy. And so we would like to simplify this, and to simplify it requires that we reduce it. And of course, to reduce it means that we have to factor the numerator and the denominator. So let's get started here, and let's concentrate on what we see on the top. And what I'd like you to recognize is the only addition or subtraction that's outside parentheses is that minus sign. And so that minus sign, as we've seen before in something that looks like this, that minus sign is a separator of the two terms. And so we're going to look at the first term on top, okay, that first term, and compare it to the second term on top, and see if either of those terms have factors that are common. And immediately I'm noticing an x minus 1 in both of them, so I know that there's some factoring that can be done. So we're going to look for the greatest common factor on top, but I look at the 3 and the 2, and the 3 of the 3x squared and the 2 of the 2x cubed, and 3 and 2 don't have any common factors. but I see next the x squared and the x cubed. And so x appears as a factor in both of those, and so we use the smaller of the exponents to factor out. So we're factoring out an x squared. And then I notice we have an x minus 1 in the first term, squared of course, and an x minus 1 in the second term. So x minus 1 is a common factor, and the smaller of the exponents is 1, and so I'll just say x minus 1. Now, we normally put parentheses, but since this is so complicated, we're going to put brackets. And of course, there's going to be a right-handed bracket too. But remember, we're going to take this x squared times x minus 1 and multiply by something to give us this first term on top. So we've got to get a 3x squared times x minus 1 squared. So we need a 3. We've already got the x squared on the outside. X squared times 3, of course, is 3x squared. Well, we have an x minus 1 to the first power, but we need to create an x minus 1 to the second power. So we need another factor of x minus 1. Then we deal with that minus sign. That's what goes here. And now we've got to create with multiplication that second term. And we need to say, okay, well, we've got to have a 2 because that second term has a 2 and we have no number in the common factor. And let's see what else we have here. Well, we've got an x squared on the outside. We've got to multiply it with an x on the inside to get the x cubed of that 2x cubed. We have an x minus 1 on the outside, and we just need an x minus 1, so we don't want to put any more x minus 1s with this term, and so that's actually where we close that off. And of course, then we have x minus 1 down here to the fourth power. Okay. Now, as we've done before, what we'll do is we'll simplify what's in those brackets before we continue. So in those brackets, 3 times x minus 1 is a 3x minus 3, and of course we have a minus 2x there. And of course this x minus 1 to the power 4. And then we see that we can actually simplify. We have a 3x minus 2x on the inside, which is just x, and a minus 3. And so I've replaced the brackets with parentheses just to make it look more normal. And then I have an x minus 1 to the power 4 on bottom. Now here's the next note, just as what we would normally do. If I have a y over a y to the fourth, we recognize that's 1 over y cubed, don't we? So I mean, that's really what's going on is we have a y over a y times a y times a y times a y, and so one of those is canceling, and that leaves 1 over y cubed. That's the idea. Now, it doesn't really matter as long as I called it y here. We can see x's, but see what we have over on the right side. We have an x minus 1 factor in the numerator and an x minus 1 to the fourth factor in the denominator. And that itself reduces to 1 over x minus 1 to just the third power, just like we did with the y's above. So we're using that idea to simplify this fraction further. That is, this x minus 1 is going to cancel with one of the 4 factors of x minus 1 in the denominator. So when that cancels, what we're really doing is we're going to change that exponent to a 3, aren't we? So it's going to end up being x squared times x minus 3 divided by x minus 1, not to the fourth power, but to the third power. So we've simplified that fraction completely, and that was quite some work, but we'll need to be able to do that in this class. Well, we're going to continue talking about one other topic with rational functions, and that's how we rationalize the numerator or rationalize the denominator. And so I'm going to pause for now, and we're going to go to the next page, and we'll talk about how we accomplish that. We're going to need to be able to graph lines, the equation of a line based on